So when we are solving inequalities, we remember to flip the inequality sign when we divide or multiply by a negative number. We solve them like a normal equation. So this is a good example of having to flip the sign. When we graph on the number line, put your answer in the middle, one number on either side. You don't need to go further than that. And then graph normally. Remember that this symbol means what kind of dot? Closed dot. And I would shade or draw an arrow which way? To the left. Okay? So that's what that looks like. This interval notation thing, we will talk about it more in Unit 2 with function notation. This is the one with the parentheses and brackets. This could be represented a second way by saying since y has to be less than or equal to -6, y can be numbers from negative infinity on up to -6. I don't know why I put an 8. I don't know. Got to get back into my infinities. And you would use a bracket because of the equal to. If it was not equal to, you would use a parentheses. Infinity is always parentheses because we can never get to infinity, right? Okay? All right, so checking out your work for example 1 and 2. Any questions on the basic inequality stuff? Okay, let's talk and or. Number 3 is an or inequality. I heard some of y'all talking about it. Or inequalities are handled like normal inequalities, which means that we solve both of them and just solve them separately and graph them on the same number line. Okay? So, when I see example 3, I'm going to solve this one. I'm going to take and subtract 5. I'm going to divide by 3. And I'm going to get x is less than -4. Or I'm going to solve the second one. -4x is less than or equal to 12. Divide. Flip the sign. When I divide by a negative, I get x is greater than or equal to -3. When I graph these, I put, here's -4, here's -3. I might throw in -2 and -5 just for one on the other side. I would have an open circle at -4 going to the left. I would have a closed dot at -3 going to the right. Any issues with that? No. No? Okay, now interval notation. This means I'm going to have two separate parts with the u. Yeah? The left one I'm going to write as negative infinity up to -4 with what sign? Parentheses. Continuing on, I would pick back up with a bracket at -3 and continue out to infinity. Yes. Yes, sir.
What does it change if it's...
So when I solve an and one, your goal is to get x by itself in the middle. Technically, yes, that kind of means there's 3 sides to the equation. There's the middle, there's the left, there's the right. So if my goal is to get x by itself in the middle of those bars, what do I need to get rid of that's with x?
Add the 8 on both.
Okay, so I'm going to add the 8 here. That means I must add it to the left and to the right. This will give me 4 on the left. I'll be left with a 2x in the middle, and I'll have an 18 on the right. Still, goal is to get x by itself in the middle. Now what do I need to get rid of? Divide everything by the 2. So this is going to leave x in the middle between 2 and 9. This is saying this in words. X is greater than 2 and x is less than or equal to 9.
When you set it up on like the line, could you just do like a 1, 2, 3, and then go to...
Yes. I would probably just, if it was me and I was being lazy, you'd see me do that. Because, like, am I honestly really that worried that you know what numbers are between 2 and 9? Like, is this what I'm testing at this point? No, not really. So I don't care. The main thing with this is where do you shade on this kind? Or draw your lines?
In between.
In the middle. Yep. So I would do an open circle at 2. Why an open circle?
Because it's
Not equal to. Closed circle at 9. These are always shaded in between. Always. X is between those two numbers on the inequality. That's what it should look like on the picture. Okay? Notice when I wrote it in words as well. This is, if you're going to read the answer in English, you're going to read from the middle. So it looks like a less than sign here with the 2. but you're reading from the middle. This would say x is greater than 2 if I'm reading it that direction. X is less than or equal to 9. Okay? So you read it from the middle if you're going to split it up. But typically, you leave your x in the middle, shade in the middle. Are those a little more, are they familiar at all? Have we ever done those?
So it would just be parentheses 2, comma 9.
Yes. So my interval notation would be parentheses 2, comma 9, bracket. And if you're picking it up, hopefully, the open circles go with parentheses, closed circles go with brackets. Infinity is always parentheses because of our lovely math theory that you can never actually equal infinity. Okay? Now let's talk inequalities with absolute value. They work the same way, but you do have to know briefly one type of rule with that, and that is this. Okay? I stole Miss Napier's notes, and I'll be honest, I don't know her blanks. Okay, when solving absolute value inequalities, you must write either and or inequalities from either one. Okay, so if it is, here's your rule of thumb. This is really the part that matters. Okay, if it is less than, if you have absolute value of stuff that is less than 2, you write it as an and. Okay, therefore, an and inequality is always written how according to our previous page?
With the x in the middle.
With the x in the middle. So you would write your answer here with -2 is less than stuff, according to her, which is less than 2. You would put your stuff in between the 2 and the -2 when you split it up. Because you know, when you are doing the absolute value, this is where you set up two equations, where one is equal to the answer and one is equal to the negative answer, right? That's how we do absolute value. With inequalities, we just do it where we flip the sign as well. So if it's a less than symbol, you are always going to have it as an and. If it's a greater, it's always an or. And this is kind of how she teaches for how to remember these. Okay, I think Miss McKinley used the same thing last year. Okay, if it's less than, it's an and. If it's greater, it's an or. Okay, so for the or ones, you don't change it. You solve, and you would keep your stuff is greater than 2 or stuff is less than -2. You would not write it any different. Or ones are written with the word or and are written with it in between. Yes, ma'am.
What do you use the union then for which one?
The union would be with the ors because they're typically in 2 sections.
Oh, right.
Okay? So let's just work on setting those up. We have 4 examples below, and then we will move on to some more factoring fun today. Okay, so when I look, yes, ma'am?
What's the union one, or did I not?
The union is for the, where we use the U in between 2 sets of answers with the interval notation. We did that on example 3 on the previous page, where with the or, we had 2 sections to our answer. So we wrote -infinity up to -4, and then a U is the union. And then we wrote -3 up to infinity for our answer. Okay. All right, let's take a look at example 1 and 2 below. Example 1 and 2. The first thing that I identify is when I have an inequality with an absolute value, is it a less than or is it a greater than? So the first 2 are both less thans, which means we are going to write them both which way? And or? And. If it's a less than symbol, it's an and. If it's greater than symbol like 3 and 4, it's an or. So this means my setup, okay? Usually when we do absolute value equations, this is what we do. We drop the absolute value bars, and we keep it the same. We drop the absolute value bars, and we change the sign of what?
The answer.
The answer. In inequalities, we also flip the sign. Yes? However, because I know that this is an and one, I'm going to write it properly, which means how can I write this as an and with my x in the middle? I would put x plus 2 in the middle. What would be to the left? The -6. Okay, and I'm going to reverse this inequality sign when I write this. Why am I going to do that? Okay, because this stuff is greater than -6, and I read it from the middle. This stuff is still going to be greater than -6. It's just reading backwards, right? What am I going to put on the other side?
The positive 6.
The +6. Now this becomes exactly like one of those on the previous page, and my goal is to get x by itself where? In the middle. Okay? Once you get 1, go ahead and try 2 because it's very similar. We will give our answer in interval notation on this, but we will not graph. So my interval notation for this one would look like this. If you've got that one, go ahead and try 2. But that means for 3, what would my setup look like? 4x plus 5 is greater than 13, or
4x plus 5
is less than negative 13. And that would solve both. This just means when we write our answer in interval notation, this is where we're going to use that u, because we're going to have 2 separate parts. Yeah? If you got 3, go ahead and try 4. I'll put answers up to these momentarily. All right. Nice little refresh of inequalities. How are we feeling about those?
Really?
Give me all those questions. Yeah?
Yes.
Good. Perfect. All right. Now, we are going to do some of the inequality stuff that we did not do on our homework. I have yet to decide how much. It's probably going to end up being like odds or something like that because I don't need to do that many of them. But just mental note, we'll do some stuff on page 35. I'll decide after I finish the rest of it. Okay? The rest of it is algebraic expressions and equations. I would actually like to do some of the more straightforward stuff first with you so that I can spend my time on the remaining stuff. So if you will, flip with me to page 41 and 42. I know I'm skipping around. At your tables, I would like for you guys to try 3, 4, 5, and 6. These should be review solving things. Okay? 3, 4, 5, and 6. So when I get to this point on number 4, I'm going to move everything to the right. I'm going to subtract 4, which is going to cancel out the 4's. And I'm going to add x. Now when I write that on the right-hand side, I'm going to put everything in order x squared down, which means I'm going to put the x squared first and the minus 3x second. How do I solve something like this? Factor. Always look for what first? Greatest common factor. Take out that x. It leaves me an x minus 3. Great. This leaves me x is equal to 0 and x is equal to 3. Anytime you have a square root equation like this that you are solving, okay, you need to check your answers. Okay, here is why. This is defined as the positive square root. Okay? Since this is defined as the positive square root, that means I cannot have negative answers on the right-hand side. Okay? So if I go back, let's say, and I plug in 0. If I plug in 0 there, that gives me the square root of 4, which is 2. If I plug in 0 here, this gives me 2 minus 0, which is 2. Totally fine. What if I plug in 3? I do. 4 minus 3 gives me the square root of 1. Square root of 1 is 1. What about 2 minus 3 on the right-hand side? Negative 1. Okay? I know that when we square root in the process of solving, like we choose to use the square root, we can put a plus or minus. There is not a plus or minus on the left side of this formula. If there is not a plus or minus, this means that this is defined as the positive square root. Okay? Because it's defined as the positive square root, I cannot have a negative answer on the right. All right? So this means that I must check my answers and get rid of 3. When I plug in 3 on the left, I get 1. On the right, I get negative 1. I cannot have that. Okay? That is a very, very easy place to go wrong. Because if you don't remember to check your answers on that, you just miss it. All right? We're going to talk about some other places to check our answers, like 1 and 2 that I skipped and we're coming back to. Yes, ma'am?
Wait, sorry, so what do we plug the numbers in?
All right. So looking at this, algebraic expressions review, back on page 30-something. Am I lying? I think you're looking at the homework. Scoot backwards. 39. 39. We're on page 39. Okay. These look super scary, but if you remember these from Algebra 2, they're not. We don't like the adding and subtracting as much, but the multiplying and dividing are kind of like fun, I'll be honest. If you factor, see what cancels. Okay? So take a minute with number 1 And all I want you to do is factor anything that you can. Okay? Factor anything you can. All right, notice there was a difference of cubes just kind of casually thrown in there. Let's hope you remember those, right? They could reappear at any various points in our lives. So you factor everything that you can. Does anyone remember what happens from here?
You cancel.
Yay! So when it's multiplied, you can treat this as one big fraction, right? Anything that's the same, top and bottom, cancels. Okay, and it includes like on opposite things. So I can cancel x plus 3 and that x plus 3. Because if I really wanted to, I could write that as one big fraction, but I'm not wasting my space, right? What else can I cancel? The x minus 2's.
And then the x squared plus x before is just x plus 2.
You actually can't factor that one. Because
Yeah.
remember with this is where I always remember though with the cubes, you're never going to be able to keep factoring. Ever.
Really?
Okay? Never. I have never seen a difference of cubes that continues to factor as long as you take out the greatest common factor first. So this kind of helps me because you want to force this. You want to force that to factor into something on the bottom. It doesn't. Okay? This means that I am left with that x squared plus 2x plus 4 on the top. I am left with x plus 2 and x minus 4 on the bottom. Everyone always asks the question, should I FOIL that back together? I don't care. Don't waste your time, okay? I wouldn't, so why, okay? The only difference with 1 and 2 is what?
You gotta flip it.
Yes, division just means that when I factor, I'm going to flip which fraction?
The second one.
The second one and turn it into multiplication.
Yes.
So that means that I factor normally. In fact, why don't you guys do that yourselves? All right, so we love the multiplying and dividing. Yes, we love less the adding and subtracting. And by that, I mean it's like fractions all over again. Yay for common denominators. So we're going to go over 3 and 4 all together because we need some refreshers on that. If you do not remember, in order to add and subtract fractions, even one with x's and y's and all that fun stuff, you need to have a common denominator. All right. So when I am looking at something like 3, I need these two pieces to match. That is my goal. Going very slowly through this, for those of you that need that with me, I look first at the 2 and the 6. And I ask myself, how could I make that the same number?
The left side.
Okay.
by 3x and the right
I
by
need
y.
a 3 first to make that 2 a 6. But if I do it to the bottom, I have to do it to the top. That's the rule. Now I worry about the x. This is an x squared and this is a single x. I need them to be the same. You can't make them the smaller thing, so you have to make them the bigger thing. Therefore, I need to multiply this first one also by an x to turn that x into an x squared. The second fraction is only missing one part, and what is that? The y. So I multiply by the y, top and bottom. Now, I will always see some of y'all on this next step still write this as 2 fractions. Why? We just got a common denominator. We want it together. What is my common denominator?
6x squared y.
All right, I want to see you write it immediately as 1 fraction because that is our point. We don't want it as 2. We want it as 1. And sometimes if you write it as 2, then you're starting to try to add the denominators together. We don't need to do that either. Remember, the denominator stays the same. Then I worry about the top. What do I get on the top of
X plus
that?
7y.
I get a 9x from that one. There is a plus sign in the middle. This becomes a 7y. Can I actually add those together?
No.
Nope. Is it okay to leave it here?
Yes.
Yes.
Do we have
Hey.
to like cancel it?
Nope. You can't actually cancel here, and here's why. You have a plus sign. When there's a plus sign, you're not allowed to cancel. Unless you can cancel like whole factors that you factor out.
So
Okay.
if we had like a 9x plus 7y on the bottom.
Yes, then you would be able to cancel. Exactly. Now, a lot of them are not similar to that question. A lot of them are like 4 and then 5 on the back, where we have like whole factors of x plus or minus something. Okay? Whole factors, if you will recall with me, that is like one thing, like the x on the previous one or the 2 or something like that. So I can't just like add something to make the right one an x plus 4. You're not allowed to add. You may multiply. So what should I be multiplying the left fraction by? x minus 2, which is going to multiply by that x minus 3. I've got to do that top and bottom. What do I multiply the right one by? X plus 4. Now, you ready to see where we all go wrong on this? When I go through this, again, my pet peeve, one fraction. What's the common denominator? X minus 2, x plus 4. Okay. Caution to you, do not multiply that together. Okay? Don't. Ever. Okay? Never multiply the bottom together. You'll see why in a couple minutes. It's going to save you work if you don't. Always multiply the top together. So on the top, what do I have to do on the top left one? FOIL. This is going to give me x squared minus 5x plus 6. Now here's where we go wrong. What do we do on the top right?
But you have an x squared.
You distribute. Okay, but what am I distributing?
The x to the x plus 4.
Ooh, the negative x.
Oh.
Okay? Because some of us will make that first term negative because of that negative and forget about the second term. Then that's going to screw us all up. Okay?
Wait, you don't do that for the x minus 2.
Well, there you're distributing negatives because there's a negative inside of it. I'm just saying with the minus sign, it goes in front of the second fraction. So when I distribute this x here, I'm always going to distribute it as a negative x. Because as much as I would love to think otherwise, if you don't distribute the negative now, you will forget about it. Okay? So distributing that will give me a negative x squared and a negative 4x. A lot of us would get the negative x squared, and then most of us would miss the 4x being negative. We would just forget that. Okay? Now, what can I still do on the top?
You can cancel out the x squared.
Combine like terms.
To get minus 9x plus 6.
Okay, now, on these ones, here's why I tell you never to multiply out the bottom. One thing that we do at the end of each of these is we check if the top factors. If the top can factor and I can cancel with one of the x plus or minus somethings on the bottom, I have to do that. In this case, this would not help me. The only thing I could factor on the top would be a minus 3, and nothing would cancel. I don't need you to write this as the top, the negative 3 and the 3x minus 2, but I need you to check that. Okay? It can be mentally. Like I can sit here and look at this and think to myself, if I take out a 3, what am I going to get? And recognize that nothing's going to cancel. If you want to factor it out and leave it here to make sure that you always do that, you may also be my guest. You don't have to. I would accept either of these answers. What will become a problem is if you don't check this, because then you'll miss it the one time that it does cancel. Like on question 5. Let's take a look at that one. All right. Now, on question 5, if you recall when we did these, before we ever did a common denominator, we factored because we need to see if any of our factors match. So, to save myself room, you will often see me write it this way. I will say x squared minus 4 factors into x plus 2, x minus 2. And I'll just kind of scribble this out. And I will say x squared minus 5x minus 6 factors into x minus 2, x minus 3. Now, why does that help me to do that first?
You already have the x minus 2.
Yes, you already have the x minus 2.
So you only have to list it now.
Right. So I don't have to make that then be in both because it's already in both. So then I just ask myself the question, all right, what factor is that left fraction missing? X minus 3. So I'm going to multiply x minus 3, top and bottom. And I'm going to ask myself now, which factor is the right fraction missing? X plus 2. All right, so now let's get used to my favorite step. One big fraction. What goes on bottom?
X plus 2, x minus 3, x minus 2.
Good. All 3 factors. Now, take a minute and multiply out the top. See what you get. Once you cancel, I would go so far as to say I'd prefer that you didn't, because this is where I'm leaving my answer, and you're going to make me think too much when I'm grading your paper. Okay? I don't want to have to go through that. Leave it there. I'm happy with that. Yes. You can still get there.
So I ended up at 4x minus 2.
Yes.
Would I still have to factor it down?
No, so if you factored from here, yeah, you can factor with the greatest common factor still in it. It's just harder to apply some of our rules if you do that. And it works. So if you ended up with these multiplied together as 4x minus 2 on top, that's also fine. Same thing. All right, before we attack complex fractions in 7 and 8 and finish up with solving, let's take a look at 6. We need to have a common denominator. Do we have a common denominator right now? No. Good. We recognize that those are not the same in 6. Okay? But I can make them be the same with just a little bit of work. Okay? This may be one of those places that it's better to just watch. This fraction up here on the right-hand side, this is the one that looks funny to me, right? Okay? Yep. So some of us know the rule. Just take out a -1. For those who don't, here's kind of where this comes from. What I recognize on the bottom of that is first and foremost, that just looks funny. So I'm going to switch the x and the 3. Then I recognize that that's almost the same as the left one. It's just the opposite sign, right? So I recognize I can factor out a -1, and it becomes that. Now here's another little special trick. That's all on the bottom, right? I don't really want that -1 on the bottom. I don't like it there. Does it matter whether the -1's on the bottom or the top? No. So what I'm going to do is I'm going to write this like this. Am I allowed to do that? Yeah. All I'm doing is I'm taking that -1 and I'm moving it up with the 9. If you want to write it as plus -9, be my guest. If you want to write it as -9, be my guest. Either way, it's the same thing. Small amount of algebra manipulation gives us our common denominator of x minus 3 and gives us x squared minus 9 on top. Am I done?
No. X minus 3, x plus 3, x minus 3 cancels.
Yeah. If you get the negative factoring out and you don't need those steps, good. I could go straight to combining them. This does factor top and bottom, x plus 3, x minus 3, which allows me to cancel. Final answer, x plus 3. All right, 7 and 8, and then we will solve.
Wait, is there a reason you did the negative up top? Like, did you just...
Mainly because I didn't want to put a negative on the bottom on the other fraction. I needed them to match, and they still didn't, so I moved it up. Yeah. All right, 7 and 8. Does anyone recall how you were taught to handle complex fractions?
Yes.
What are we taught to do?
You write it out. So I did like 1/2 plus 1 over x, and then I did a multiplication sign, and then did 4 over x plus 3.
Okay, you can do that. That would work on 7. That would not work on 8.
You treat each fraction individually. So like the top of the fraction, like on number 8, x over x squared, blah, blah, blah. You solve for that one, and then once you're done, you solve for the bottom, and then you can just rewrite it into a multiplication.
Okay, you can. That's common denominator. Are we all okay if I teach you a shorter method?
Yes.
Okay. All right, so here's my method. And I don't know why they don't teach it in algebra 2. That's okay. This is just my personal one. I haven't taught algebra 2 in years, so I just teach this one and teach it shorter. So here's what I'm looking at in 7. These are, complex fractions are fractions within fractions, right? We have little fractions within a big fraction. Okay, so how many little fractions do you see in 7? 3, right? I've got 1, 2, 3. If I were to get a common denominator, I'm not going to, but if I were, what would said common denominator be? 4x. So my common denominator for those 3 would be 4x. Are we all okay with that fact?
Yeah.
Okay, so I am going to take all 3 of those individual fractions that I have circled, and I'm multiplying them all by the common denominator. I am going to multiply by 4x right here. I am going to multiply by 4x right here. And I'm going to multiply by 4x right here. Now, why am I allowed to do that? Because I'm just multiplying the top and the bottom by the same thing, right? 4x over 4x is just 1. Okay? So, let's take a look at what that's going to do for each of these. First, here.
So you could combine the top fractions.
You could, yes. It will take more steps.
Oh, so don't do that.
Don't do that yet.
Okay.
So this is going to get rid of all of my fractions at once. And it will be nice for me. So if I take that 1/2 and I multiply it by 4x, what do I get?
2x.
2x, right? No fraction. Okay? Let's do that on the second one. If I take the 1 over x and I multiply it by 4x, what do I get? 4. On the bottom, if I take that whole fraction, x plus 3 over 4, and multiply it by 4x,
X squared plus 3x.
okay, the 4's are going to cancel, and you can multiply that x into the x plus 3, yeah? Or you don't have to. You could leave it separate. And I might actually do that. Leave it x and x plus 3. Sometimes something will cancel with the top, which is why I tend to leave the bottom separate. Okay? Now, in this case, the only thing I could factor out of the top is what? A 2. Is that going to cancel anything? No. So I'm going to leave it here. But do we see how that's like one step rather than common denominator on top, common denominator on bottom, flip and multiply, 3 steps. This takes me much less. Always. Yes, ma'am?
Wait, so what happened to the?
All right, so start the same way we started the last one. How many little fractions within this do I have? I have 4. I have 1 right here, 2, 3, and 4. Now, I'm not going to get a common denominator, but I do want to know what it would be for all 4 of those put together. What would my common denominator be? X plus 2 and x minus 2. I'm going to multiply by it in factored form because that's going to make my life nicer. So thinking about what we did on the last one, what did we do with that common denominator?
We multiplied every single.
So I have them all in little boxes here. We're going to take each one of those, and we are going to multiply by x plus 2, x minus 2. I am going to take the time to write that next to them because I like to physically cross things out on each one. You don't have to, but I find that it helps me. Okay? So I'm going to write that next to all 4 of my little boxes here. Now, I'm going to go through one at a time. Top left one, what's going to happen on that fraction?
Gotta cancel out.
Cancel out the entire denominator because it's the same, top and bottom. What am I left with? X. All right, second, top right. What's going to cancel?
The x minus 2.
X minus 2's.
3 parentheses x.
Okay, now on the top, I always multiply out everything, so I'm going to go ahead and make that a 3x plus 6. Are we good with that?
Yes.
All right, let's look at the bottom. Bottom left, what do we multiply by? Or cancel, excuse me.
X plus 2.
X plus 2's, so I'm going to distribute there.
But we leave it like that.
In this one, I'm actually going to distribute, and here is why, because there has a plus sign. Okay? So anytime there's a plus sign on the bottom and I'm going to be able to combine like terms, I'm going to do it. Okay? Notice on the last one there was only 1 fraction on the bottom. That's why I left that one separate. This one has 2. I'm going to put those together. So this is going to become 5x minus 10. Bottom right, what cancels?
X minus 2.
Okay, and that's going to give me a 4x plus 8. On both top and bottom, I'm going to combine like terms and see if anything can cancel. Okay? This will give me 4x plus 6 over 9x minus 2. I can recognize that the bottom is not going to factor, so I'm not going to bother with the top. Okay? Fair enough?
Fair enough.
Last but not least, are 2 solving. Now, the reason I teach those like this is because that's how I teach solving too, which means they go together to me. So our last 2 questions of the day are 1 and 2. These are very similar, and a lot of people have been taught in 1 and 2 to get common denominators and put them together. I personally teach canceling it out with the common denominator just like I did on complex fractions. So like on 1, how many fractions do you see? 2. What would be the common denominator of those 2 fractions? X plus 5 along with x. So what I'm going to do is just like with the complex fractions where I multiplied everything by that common denominator, I'm going to do that here too. I'm going to multiply all 3 terms by x and x plus 5. But don't forget the answer. All 3 terms. Yes, ma'am. On the first fraction, what's going to cancel? The x. This is going to leave me a 6 multiplied by an x plus 5, which I'm going to call 6x plus 30. On the second fraction, what's going to cancel? The x plus 5s. That's going to leave me 8x. On the right, it was not a fraction, so nothing cancels, but I'm going to go ahead and distribute. 3x into x plus 5. 3x squared plus 15x. How do I solve something like this?
Move it to the other side.
Move everything to one side and what? Factor. Yes? Combine like terms and factor. See if you can finish solving, and then we're going to talk about one hang up on these kind of questions. What are you not allowed to have on the bottom of a fraction? 0. You are not allowed for x to be 0, or when you plug in x to have 0. Okay, so this is ones where it says always check your answers. Here's the thing though, guys. You're smart enough to know this just like I do. If I look at the beginning equation, before I ever get started, I know which answers I would have to get rid of. Because it's not that there's a bunch of answers you have to get rid of. It would only be particular ones. For example, this x by itself on the bottom tells me I can't have 0 as an answer, right? Because if I got 0 and plugged it in right there, I'd have 0 on the bottom of the fraction. What does the x plus 5 tell me? I can't have negative 5. So rather than think I always have to check, I kind of have a mental idea at the beginning of these. I know I can't get 5 or 0, negative 5 or 0 as an answer. All other answers are fine. Those are the only two I can't have. So I know that going into it. So now when I look at my answers, do I have 0 or negative 5? No, so it's not that I'm actually plugging these in and seeing what I get. I just know which ones I can't have. Does that make sense?
So the only ones that don't work are as if it equals 0.
Yep. And it's easier for me to think that way than to think through plugging in negative 10/3, especially if you don't have a calculator. So like looking at 2, someone tell me right off the bat, what can I not have as answers? 3 and negative 3. Those are the only two. Okay, so I know before I ever start 2, if I get 3 or negative 3, I just cross them out. And then I go from there. So for 2, I would still factor anything I can in the denominator before I get started. What's the one thing I can factor? Okay, this is x minus 3x plus 3. And I would start it the same way we did the last one. Multiply by what is the common denominator of all 3 of these fractions. So if you put all 3 parts together, what would be a good common denominator? X minus 3x plus 3. And I'm going to write that next to each of my 3 fractions. Again, I like to physically cross things out on every single one. So some of you are with me. I know. I saw the nodding heads. You can be a little type A like I am. All right, so on the first one, the left fraction, what's going to cancel? The x minus 3s are going to cancel right here. What do I have to do on the left then? Foil it, right? That's going to give me x squared plus 5x plus 6. Now I move to the right side. That first fraction, what's going to cancel? Both. So you just have 30. The second fraction, what cancels? Okay, so I'm just left with. And how do I solve something like this? Okay, so everything on the right moves to the left. So first I'm going to recognize that this gives me 27. I'm going to subtract x from this x. So this gives me 4x. And then subtracting 27 gives me negative 21. What factors of negative 21 add up to 4?
X plus 7 and x minus 3.
Okay. So I set my factors equal to 0. Now, because I thought about this question in advance, what do I know?
3
Does not work for 3. Okay? And if you go back and plug in answers, please don't plug them in through the whole equation. All we care about is what gives us 0 on the bottom. In those fraction problems, 0 on the bottom is the problem. That is it. Okay? If I crossed out both, what would be my answer?
undefined.
Undefined or no solution. That is possible. It happens sometimes. Okay? All right, so what we are going to do is we are going to be done.